Okay, so now we're going to talk about graphing quadratics and graphing in general using this program called Desmos. Okay, this is a great program to use. It's basically a graphing calculator app. It does a lot more though. Your graphing calculators, your TI-84s or 83s or whatever version you have, can also do all this stuff as well. But since I know not all of you have a graphing calculator, we're going to use Desmos for this. I'll put the steps for the graphing calculator up in a separate video or just as a document on the classroom. All right, so let's start by going to, I'm going to try to split screen this. I don't know if it's going to work. We'll find out. We'll start by going to www.desmos.com, or you can download the app on your phone. The app on the phone, it's the exact same as the website version. Okay, so I already did this on the right screen. And then at the top, it should say start graphing. So let's start graphing. Now you can make an account. You can make an account through your school account, through your school email account. You should be able to click sign in with Google and it'll automatically make an account for you. But you don't need an account. You could just use it for free without logging in or anything. All right, so you could type in any form of an equation. So we're dealing with quadratics, so we're going to graph quadratics today. But you can graph linear equations, you can graph trig equations, you can graph exponentials, you can graph anything. Any type of math equation you want. You can do circles, use shapes, anything you want. So you could type in any form of any equation. So if you think quadratics, you could do vertex form, factored form, standard form. It doesn't have to be in a form at all. Whereas your graphing calculators have to be in y equals form to graph. And then there's a couple shortcuts we're going to be using. I call it the caret, but it's shift 6. That'll insert an exponent. If you want a fraction, you just do the slash bar. So like 1/2 will automatically write it as 1/2. And you could put y equals, you could put f of x equals, you could put whatever variable equals, or you don't have to have an equals at all. You could just type, x plus 2, and it'll graph the line x plus 2. All right, so let's start with the practice problem. Again, I'm going to try and write on both of these, but I don't know if it'll work. So let's type this equation. So it says graph y equals 1/2 x squared plus 4x minus 1. All right. So just on your keyboard, y equals. Now at the bottom left corner, there's a keypad. This has all the symbols and shapes. We don't really need any of these today, but let me get this out of here. Oh, all right. We don't really need this today, but it's there if you need it. All right. So y equals, and then 1/2. So 1/2, and it automatically inserts your fraction. Now you want to use the right arrow key to get out of the fraction, otherwise it'll keep typing in the denominator. All right, and then x, shift 6 to get the exponent, and you'll see it goes up to the exponent. And then squared. Okay, and it graphs it as it goes. Okay, so before we had the square, it was a line because it was a linear equation. We add the square, it becomes a quadratic. It graphs the parabola. Let's keep going. Plus 4x minus 1. Okay. All right, so we have the graph of the parabola. Now, again, if you're doing full screen, yours is going to look a little better than mine. One thing to notice is, as you hover over the graph, these points pop up. These are all the key features of your graph. Okay, so it'll automatically tell you without having to do any extra work what the X-intercepts are, what the vertex is, and what the Y-intercept is. Okay, so we'll go through and I'll try and write on this. Here we go. Find the vertex. Okay, now again, you could just hover over where the vertex is, or you could click it, and it tells you the vertex, -4, -9. I don't know if I'll be able to write on this. All right, good enough. Find the X-intercepts. Okay, now again, normally without graphing, we have to find the X-intercepts. We have to factor it. Now this is unfactorable, so it'd be impossible. You'd have to use the quadratic formula. But instead, we could just graph it and find the X-intercepts this way. So your X-intercept on the left side is -8.243. Okay, now in using quadratic formula, that would be some square root, some radical thing. But Desmos will give you the decimal version. So let's go -8.243. Okay. And then again, it's a parabola, so there's going to be another x-intercept on the right side. Now, if you click it, all these important, if you click the dots, the points stay highlighted, or you can just hover or unclick. Well, all right, and the other one is 0.243. Oops. All right, 0.243. All right, so this writing isn't going too well. That's all right. It's a thought that counts. Find the y-intercept. The y-intercept, we already know the y-intercept because it is in standard form, and we know the y-intercept is always a c value. So we know it should be -1, but the graph should, confirm that. And it does. It is -1. So the y-intercept is 0, -1. Okay. All right, and those are the key features of the parabola. But there are other parabola questions we could ask. There are other quadratic questions we could ask. Find the output when x equals -6. Okay, so one way we could do that is we could plug in -6 for x. That would be solving it algebraically. If we want to solve it graphically, well, we just have to figure out when x is -6. So you could try and go to the x-axis, -6, and kind of go down and click on the graph. And you can make any point you want. Okay, so -6 is right there, -6, -7. Okay. Now it is hard to kind of get that exact point. What if we do want that exact point? And what if it wasn't a nice point like -6, -7? Well, you can make another equation. Find the output when x equals -6. You can just type that in as equation, x equals -6. And the answer is going to be where those two lines cross. Okay, so you got a vertical line, x equals -6. Wherever that crosses the parabola is going to be the answer. So -6, -7. So when the output when x is -6, which means the y value is -7. Okay. All right. So we don't need that anymore. So you can click the X and get rid of that. You could also change the colors on here. There's a lot of settings you could use. If you want to change the color, blue's a nice color. You do that. And then the last part is find which x values give you an output of 2. Okay, so same thing. This time an output. So we're trying to find x values that give you a y value of 2. Okay, so you go to 2 on the y-axis. It's over here. We know our answer is going to be, somewhere over here and over here. Okay, but they're not nice points. Okay. And it's going to be hard to get exactly 2. So that's pretty close. 0.7 gives you an output of 2.045. But we want to be exact. So we're going to do the same thing. An output of 2, output of +2 is when y equals 2. We're trying to find the x values when y equals 2. So you just type in y equals 2. Okay. It graphs that horizontal line, and wherever those two lines cross are going to be your answers. So which x values give an output of 2? Well, it's -8.69 and +0.69. I'll try to write those. -8.69. Oops. And 0.69. Okay. Usually I write on the tablet flat, but it's not flat because I have to type. All right, so that's that graph. And again, you change the shape of it. You could change the color. You could make it a thicker line, a skinnier line. You could get rid of the line altogether if you just click the circle. There's a lot of options you have. All right, now one option is you could also drag the graph around, maybe, yep, and kind of see different parts of it, or you could zoom out and zoom in. So on this next one, we're going to have to use that feature as well. Okay. All right, so number 2 says find the vertex of f of x equals -2x squared plus 41x plus 22. And you could type it exactly as you see it. You could put y equals instead of f of x equals. You could not put anything for that equals. I'm going to type it as I see it. So f of x equals -2x shift 6 squared plus 41x plus 22. Okay. All right, well, that doesn't look like a very nice parabola. Okay. I'm going to go full screen for this one, make it a little easier to see. Nope, maybe not. There we go. All right, so that's our parabola. It's not a very nice looking parabola. We can't really see all the parts of it. Okay. So what you want to do is you're going to have to zoom out. Okay, so we'll zoom out. You could scroll. You could hit that minus sign at the top corner. But what happens is it zooms out. It zooms everything out. Okay, so now we see the vertex. And again, these points tell us the important values, the X-intercepts, the Y-intercepts, and the vertex, which is up there. But it's not a nice graph to look at because, we have all this white space over here. We don't really need all this space to the left and right. We just needed the space above to find the vertex. So what you could do is you could click this wrench in the top right corner. Okay, this wrench gives you a lot of options. Projector mode makes it thicker, so if I was projecting this, it would be easier to see. Reverse contrast, I don't know what that is. Oh, that's cool. I don't know, didn't know that was there. Braille, I don't know what that does. Okay, Braille. That's cool. Grid, arrows, so you could turn the grid off and on. You could turn the axis numbers off and on. Minor grid lines off and on. Arrows, if you want arrows. So there's a lot you could do there, but what we're going to look at is this window. So look at our graph here. We have all this white space over here. We don't need all that white space. We just want to look at the X-intercepts and the vertex. So we're going to change the X-axis. We're going to get rid of all these numbers, and we're going to pick a number that makes more sense to us. So let's do like -10. Okay, you want a little bit of space to the left so you can see more of the graph, but you don't need a lot. And then our X-intercept is at 21, so let's put the maximum X-axis at 25. So give us a little bit of space. And then again, we don't need all this extra bottom space. Okay. So let's do like negative, and you want to do it proportional. So we know, our top here is up around 250, so maybe we do -50 to give us a little space at the bottom. And 281 is pretty good, but let's just go 250. All right, so this is a much better window to look at your graph from. Okay, you could see, the shape of it better. You could see the X-intercepts, you could see the Y-intercept, you could see the graph, and it's not just some skinny little thing with, the points that it shows you. So changing the window is important, and again, you could do this on the graphing calculators as well. All right, so that's the vertex, if you want to write that down, and on the paper, if you want to write down the, the forms, the boundaries we used for X and Y. All right. All right, but now let's get into the real reason why we're doing this. So that's, those are just basic graphs. But the real reason is we needed to solve that problem from yesterday. Okay. So the problem from the last lesson was this increase-decrease problem. Popular purse designer sells, or a popular designer purse sells for $500, 45,000 are sold each month. The company did some research and realized that for each $20 decrease in price, they could sell 5,000 more purses per month. How much should the company charge to maximize their monthly revenue? Okay, and then we set up this equation. We solved it. If you want to, we go through how we got that. That's in the previous video. But we realized that we need to find the vertex. Okay, now finding the vertex from this equation would be kind of difficult. We'd have to, factor or FOIL, and then, opposite B over 2A, and, it's just not that nice of an equation. So instead, we could graph it. We're going to graph this in Desmos. So 500 minus 20x times 45,000 plus 5,000x. You could type that exactly as you see it into Desmos. Okay, so let's do that. All right, we'll get rid of this. We'll get rid of this. Okay. And we'll just try and center that. All right, so our equation was y equal, or it wasn't y equals, it was r of x equals. Again, you could use r of x equals 500 minus 20x. And then times, you don't have to put a time symbol, but you can. It's in the keyboard. or you could do Shift 8. I'll give you the star. And then the other one was, I don't remember. 45,000 plus 5,000x. Okay, so we'll type that exactly as we see it. 45,000 plus 5,000x. All right, and that's our equation, and this is our graph. I'm going to change the color to, I don't know, green. Okay, this is a profit equation, so green for money. All right, well, where's our graph? All I see is this line. Okay, I'm going to put projector mode on to see it. All right, all we see is that line, okay, which means, you know, our graph is somewhere out there. We know it exists. We know it's over there. So we zoom out a little bit. Okay, well, now I got two parts of the line. I know my vertex is going to be up there somewhere, so I'm going to keep zooming out, zooming out, zooming out, out, out. All right, this one's a little bigger than I thought. All right, there we go. There's the top. All right, so we see it finally ends. This again, these are a little bigger than I thought it was going to be. It's hard to see, so if you just click, it'll automatically tell you the vertex. That's the vertex. So that is 8, 2.8 million. Okay. All right, well, let's see if we could change the window on this and see it a little better. Our X-intercepts are fairly low, so our X-axis doesn't have to be this big. So let's go, I don't know, let's go -10 to 40. Okay. And then, you know, the Y-axis is actually not that bad right here. So we'll just leave that as it is. Okay. And this is easier to look at. So now we can find the X-intercepts, we can find the vertex, and we can see the shape of it better. Okay. Now remember what everything means in here. The Y-axis is profit. That's how much money you're making. That's revenue. It's not profit, it's revenue. And the X-axis is the number of price decreases. Okay, so you're decreasing the price by $20 each time. This is the number of price decreases. So what happens if you decrease it 10 times, 20 times, 25 times the X-intercept? We want the vertex, though, to maximize the revenue. So the vertex is 8, 2.8 million. Okay, so we write that down and finally answer the rest of our problem. Okay. So find the vertex. Okay. The vertex was 8, and again, it gave Desmos gives you in what scientific notation, but it was what 2.7 or 2.8 million. So we'll write that out. Okay, actually, it's not 2. I went back and checked. It's not 2.8 million. It's 28 million. Okay, 2.8 times 10 to the 7th power. So that's 28,900,000. So we'll fix that on our page. Let's get rid of all these. So 28,900,000. You might not want to put the comma in, just because it'll confuse the ordered pair. All right, so you got 28 million as your Y value for the vertex. All right, but that's the vertex. That's the vertex of the equation we wrote and graphed. It doesn't answer the question. So, okay. The question refers back to the context of the problem. How many decreases should be made to maximize profit? Well, remember, the number of decreases was X. So to maximize profit, that was going to be the vertex. So this is asking for the X value of the vertex, which is 8. Okay. So 8 price decreases should be made. How much would the purses cost if you make 8 price decreases? Well, remember, the price part was this equation, that linear part. So our X value is 8. So we're going to do 500. Each price decrease was $20, so 20 times 8. Just plugging in for that. And it gives you 340. So you're going to be selling these purses that were $500, you're going to sell them for $340. How many will be sold? Okay. Well, number sold was this part, the 45,000 plus 5,000 times X. So we could plug in 20 for that X value. 45,000 plus 5,000. So every price increase that you're going to sell 5,000 more purses. And we're increasing it 8 times. Okay. So that gives you 85,000. Okay, so again, originally we were selling 5,000 purses for $500. Now we're going to be selling 85,000 purses for $340. And that's going to maximize our revenue. How much profit will be made, what profit will be made, or what revenue will be made? Well, we don't have to find that. We already found it. It's the Y value, what this equation equaled is revenue. So the Y value of that vertex is the revenue. It's 28 million. $28,900,000. Okay. And then I added an extra question. When will they stop making profit? Okay. Or again, revenue, it should be. Well, if we go back to the graph. So back to the graph here. When will they stop making money? When will they stop making revenue? Okay, well, that's going to be when your parabola, when the graph dips below the x-axis. So everything above 0 on the y-axis is money. That's revenue. That's money they're making. Anything below it would be money they're losing. Okay, any negative y value is money loss. So the point when they stop making money is going to be the point when they hit the x-axis, the X-Intercept. Okay, so they're going to stop making money if they do 25 price decreases. Okay. Now if we go back to the equation or the problem, that should make sense. If they do 25 price decreases, okay, so we'll say when x equals 25 decreases. If they do 25 price decreases, 25 times 20, again, it's a $20 decrease. 25 times 20 is 500. Okay. Well, if you go back to the problem, the price was 500. So if you do, that's basically saying they'd be selling the purses for $0. If you sell something for $0, you're not going to make any money. Okay. So if it asks for when do they stop making profit, when do they stop making profit, or when do they stop making revenue, that's going to be when it hits the x-axis. Okay, because the x-axis is 0 for y, 0 for revenue, 0 for money. It's going to be the x-axis. Okay, and again, this should make sense. If you sell a purse for $0, you're not going to make any money. All right, but that's the intro to Desmos. Again, this problem was a little weird just because the numbers were so big. But we're going to have one for homework that will be a little more reasonable. And again, just, play around in Desmos. It's a great tool to have. The Chromebooks have it. Again, you could have an app on your phone. You get to use it on the state tests, which we're not taking this year. But, it's a great tool to, learn how to use.